So, let's see. I'm trying to figure out, where did we leave off? I think we left off talking about lines and circles, right? Is that right? So I think it would be in your best interest for me to work at least like at least another couple of the circle problems, because there's completing the square in that, and sometimes students have trouble with it, you know? So let's look at an example. Find radius and center of circle given below. So here's the circle we'll look at. X squared plus 6x plus 2y squared. Oh, goodness gracious, I can't do that. I'm about to make your circle into an ellipse. That's not allowed in here just yet, right? X squared plus 6x plus y squared minus 10y equals to, I don't know. 12, maybe? All right. So what does the circle look like? Remember the standard form of the equation? What's our goal? So we need something like x minus h squared, right? Plus y minus k squared equals to r squared. This would give me a circle with center h comma k and radius r, right? So can we do algebra to make this other equation look like that, right? So what we're going to do is we're going to complete the square. So can you guys get me started? X plus what squared? I heard a 3, I heard a 2. How many votes for 3? Votes for 3? You guys don't believe in voting? Yeah? 3? Yeah. So, okay, there we go. That's not how voting works. You should have at least like 2 choices, right? Yeah. Sometimes you feel like you have no choices, though, you know? Let's see here. So, minus 9, to be fair, right? Because if I do x plus 3 squared, I get x squared plus 6x plus 9, right? There's no 9 here to start with, so I have to subtract 9 to maintain equality. So what I'm doing is I'm taking these 2 terms, and I'm rewriting it as the difference of that square and 9. This is called completing the square. So you take half of the coefficient of x, and then you subtract the square of that. And then, how about the other one? Plus what? Y what? Squared. Plus 5? Almost right? Yeah, minus 5 because we had a minus 10, but heart's definitely in the right place. Let's see here. And then, so that means I've added 25. To be fair, I have to subtract 25, yeah. All right. And that is exactly equal to what's underlined in red above. Right? And now all of that's still equal to 12, right? That was neat. I like that. Let's see here. So we need to add 9 and add 25 to both sides, right? What does that give us? What's 9 plus 12? 9 plus 25 plus 12. I heard a 46. Well, well, I'll write it down. 12 plus 25 plus 9, right? So I think 46 is right. 12 plus 25 is 37. 37 plus 9 is 46, yeah. You're right. So you're 46. And then we got to use your imagination. That's the square root of 46 quantity squared, right? And then the game we play is just matching, right? Like this is an important part of math, is just pattern matching, right? So what's the H, what's the K, you know? So we find circle at -3, 5 with radius square root of 46. So there you go. Any questions? Why does it have to be squared? Well, I'm trying to, the point is I'm trying to compare. I need to match. I mean, there's different ways you could think about it, but I'm basically trying to compare this expression to that expression. Another way you could look at it is we could say, well, 46 equals to r squared, right? So if I solve for r, what's that give me? R is plus or minus the square root of 46, right? But we assume r is positive, so we choose the positive solution for r. Like, if somebody tells you that the radius of the circle is -3, you're going to tell them, like, shut up, go away, you know? No, not allowed. Does that seem reasonable? We could draw a picture of it. Where is this circle? -3 over, and 1, 2, 3, 4, 5 up. I regret where I drew the axis at this point. The square root of 46 is between what? It's between 36 and 49, right? 36 is square root 6, 49 square root 7. So that's like, yeah, 6.8, 6.9, something like that. Which means that that circle goes all the way down 2, 3, 4, 5, 6, about down to here-ish in my picture. So this is going to make a mess of my problem, but I'll do it. So roughly speaking, that's the circle that we just found. Oh, here. There you go. Oh, that's fine. That's fine. So yeah, there it is. Any questions? What if I gave you a picture of a circle and asked you to write down the equation? We could have that problem as well, right? Kind of like the opposite problem, the inverse. So here, let's do that. Suppose my circle has center, I guess 2, 3, and suppose that another point on the circle is 0, -1. So these are 2 points on a circle. And I will tell you in addition that this is the center of the circle. Well, these are not 2 points on the circle, rather. 2, 3 is the center. And 0, -1 is on the circle. Find its equation. How would we do this? What's that? Ah, okay. Oh, great. Yeah, x minus 2. Uh-huh. You gotta find the radius, right? How do we find the radius? Like what's a geometric definition of a circle, right? A geometric definition of a circle is it's a set of all points that are equal distance from the center point, right? Like that's the way we can define a circle. That's why compasses work, right? You stick your point in the middle and then you sweep around. That gives you a collection of points that are all the same distance from the center circle. Or if I had a yo-yo handy, you could swing it around. All the trace where the yo-yo traces out, they're equal distance from the pivot point, you know. But yeah, that's the question: is how do we find r? How do we find this distance, right? It's the distance between what? 2, 3, and what? Yeah, 0, -1. How do we find the distance between 2 points in the plane? What do we use? What's that? Slope? Well, there's something called the distance formula, right? So, I mean, you can visualize it in terms of the Pythagorean theorem, right? Like if you put this point is x1, y1, and this point over here is x2, y2, and if you wanted to find this distance, you could visualize there's a triangle here, right? And this one is delta y, and this one is delta x, right? And so the distance, let me call it d squared is equal to delta x squared plus delta y squared, which would be like specifically x2 minus x1 squared plus y2 minus y1 squared, right? So we can understand the distance formula coming from the Pythagorean theorem. And so for our example, what's the distance that we're interested in? Square root of what? 0 minus 2? I mean, you could do it either way, right? I'm just taking 0 minus 2 plus minus 1 minus 3 squared. Maybe you did 2 minus 0 plus 3 minus a minus 1 squared. Oh, yeah, go ahead. It's fine. So what's that work out to? I think that's a 4. Yeah. 4 plus 4 squared, right? So 4 plus, right? What's minus 4 squared? 16, right? Yeah, that's fine. So square root of 20. So that tells me that exactly. So the answer square root of 20 squared, right? So we can just put 20 here, right? So there you go. Now, the other way you could have solved this would have just been to plug in. You could have just plugged in the point 0 minus 1 into this equation and solve for r. That's another way you could have done this. If you didn't have this geometric idea that r is the distance, so we just find that, right? How many points does it take to determine a circle? You're like, well, you just gave me 2 points, didn't you? Right, but that middle point's a special point, so that's kind of a, like how many points does it take to fix a parabola? A typical, what's that? Yeah, parabola. 3, right. Unless I give you the vertex. The vertex in any other point will fix a parabola. But the thing is, the center of the circle is special, right? Generally speaking, if you start thinking about it, you need 3 points to fix a circle. We need 2 points to fix a line, right? If you give me 3 points, there's really no guarantee that those 3 points are going to be on the same line, is there? Right. I think if you give me any 3 points, I can find a circle through those 3 points if you start thinking about it, right? But anyway, that's, that's a pretty good example. This is a pretty good example. I think I'll stop there. I think you probably don't need to see me do more on finding equations of lines that much. I'll do one more. I think I have a weight. Ow. This is surprisingly sharp. We're supposed to next talk about systems of inequalities, right? Well, visualizing inequalities graphically, right? So let's talk about that. So I will start with just some real simple, really simple examples. It's okay. Well, I mean, is it? No? Okay. If it's a question about like what we're doing next, then I'm always interested in those, but, it's fine. Where was I? Oh, yes. Visualizing inequalities. So a really simple example. How about x greater than or equal to 3? What would that look like if you wanted to visualize it? If I wanted to plot all the points in the plane that satisfy that inequality, what does it look like? Yeah, x equals 3 is a vertical line. Right on board with you. And then what does it mean x is greater than 3? It means it's what? It's to the right of that line, right? So the solution in this case is like a half plane, right? It's like everything. This one lived a good life, but I think it's over. Hey, where'd my trash can go? Try not to hit you guys. Oh, man. That was. You can throw it back. You throw it back. I got to try again. Just that area right here. Oh man, I'm just. Oh. I'm out of practice. I need to throw more markers. Uh-oh. Judge not, lest GB. It's harder than it looks. All right, let's see here. Another example. And I like this is example I discovered. Well, I mean, anyway, here's one. XY greater than or equal to 0. Right? We could look at that. That's another kind of neat example. How can we let me get rid of the equality. XY greater than 0. What is that? If we think about real numbers, how does that work? It's either they're both positive, right? Or they're what? They're both. So that's what? That's like quadrant 1 or quadrant 3. So, and the axes are not included, right? So it's like up here or down here. Another example, what would happen if we instead had like xy greater than 1? weight is right, right. Let's think about this. There's two cases, right? So if x is greater than 0, then y is greater than 1 over x, right? Because we divide x to the other side, it doesn't flip the inequality, right? Excuse me. What if x is less than 0, though? Y is less than 1 over x, yeah. There's no, I mean, it's just, there's no minus in the equation, well, in the inequality. How about just beyond the solution set when we have equality? What's that look like? Do you guys know what y equals 1 over x looks like? Okay, well then how do we figure it out? How do we graph an equation or a function that we don't know? You get your graphing calculator, or you could plug in some points, right? So let's go ahead and make a quick table of values and go from there. Here's x, here's 1 over x. I'll start with like minus 2, gets my minus a half. Minus 1 gives me minus 1. Minus 0.5 gets me minus 2. Let's see here. 0.5 gets me 2. If I plug in 1, I get 1. If I plug in 2, I get 1/2. It just flips over the entry. So if you start looking at that, what you're going to see pretty fast is that it blows up, like it goes to infinity as we approach, you know, like it's getting super, super big up here, and then it kind of goes like that on that side. And on the other side, it goes to minus infinity there. See, because the closer, if I made this number smaller, if I made it like 0.01, like if I added minus 0.01, then I'd have 1 over minus 0.01, which is minus 100, for example. Like the closer you get to the negative, to the y-axis from the negative side, the smaller, the larger negative number it gets. So it just goes down and down and down. Whereas on the other side, you go up and up and up. Like if I put in 0.01, I get 100 on the other side. So we've got what's called a vertical asymptote at 0, right? 0 is not in the domain of y equals 1 over x. Okay, so there I've just graphed for you y equals 1 over x, right? And so so we either have two cases, 1 or 2, right? So case 1, what does that look like? Y is greater than 1 over x, right? So this is not actually included in the solution set, right? But up here, anything up here solves it, right? And then case 2, right? Y less than 1 over x, so that's down here. So, am I able to say anything nice, like when we look at x and y being greater than 1, like they're both larger than 1? I don't think we can say that. Can we say, I guess you can say at least one of them has a magnitude which is larger than 1 or equal to it. If you look at these, think about the pairs, like at least one of these has to have a magnitude that's larger than 1. I think that's true, but anyway, there's another one. Now, what's more likely the kind of question I would ask you is I give you a picture of a region, and then I ask you to give me a set of inequalities which describes the pictured region, right? So let's work an example like that. And this will actually bring us back to the problem of finding the equation of a line. Actually, I'll make it a sort of maximally annoying problem. We'll have to find the equation of 3 different lines. Okay? So suppose you're given points, I don't know, 1, 4, minus 3, minus 2, and over here, like 10, 2, right? And you're told that these 3 points describe the vertices of a region which is described by a set of 3 inequalities. Let me explain that more concretely. So suppose we connect the line, connect the dots, right? And so the given problem is describe the shaded region using a set of appropriate inequalities. Now, I think we might have to break this into 2 pieces if my picture is right, right? Let me explain to you why I think that. Like, if I pick a point, so now let me undo my shading because it's kind of annoying. I guess that's kind of shaded, right? But if I pick this point, right? Say x comma y like that. Sorry, it's so tiny. If I pick that point, if you think about it, x is between what? X is going to be between what? -3 and 1, right? So clearly -1 less than, good grief, minus 1. How did I get the -1? Yeah. -3 less than or equal to x less than or equal to 1, right? And if you'll allow me, I'm going to call this line 1. I'm going to call this line 2. And down here we've got line 3, just to give them labels. So like line 1 tells me the top where y could be, and line 3 tells me the lowest that y could be, right? But what if I pick the point on the other side of the triangle? Like over here, right? I mean, I think it makes sense to try to divide this problem into 2 pieces and look at it separately. So I'm going to call this case 1, and I'm going to call this over here case 2. So we'll start with case 1, and we'll figure that out, and then we'll figure out case 2. And I'll start case 2 already, though. We can see that 1 is less than or equal to x is less than or equal to what? What's the biggest x can be in region 2? 10, right. So I need to find the equations of lines 1, 2, and 3 to be explicit, right? Like, basically, okay, so let me find the equations for lines 1, 2, and 3, like over here, and then I'll use it to put the answers in 1 and 2, if that's okay with you guys. So how do we find the equation for line 1? I can't spell. I'm changing these into limes. Say line, L-I-N-E, 1. We know what? It has, we know that points -3, -2, and 1, 4 are on the line, right? So we could find the slope, right? I'll call it M1. M1, the slope for the first line would be what? The change in y over the change in x, which in this case we could write as what? Like 1 minus a minus 2 divided by, oh good grief. Don't believe that for a second. Which one's the y component? Which one's the x component? So how about 4 minus a minus 2 divided by 1 minus a minus 3. Looks like the slope should be 6 over 4, right? So I think the slope is 3/2. So that gives me y is equal to, let's say, 4 plus 3/2 times x minus 1 using point slope. I mean, we can clean that up if you'd like. Would you feel better if I put it in mx plus b format? Okay. So y is equal to 3/2 x. And what's 4 minus 3/2? 5/2. I believe that's right. Yeah. So there's the equation for line 1. What's the equation for line 3? It has what? It has, line 3 has minus 3, minus 2, and 10(2) on it, right? So the slope, delta y over delta x, right, rise over run, would be like 2 minus a minus 2 divided by 10 minus a minus 3, which I think is 4 over 13. The slope of the low line is pretty shallow, right? It's a low slope, 4/13. And using point slope, I have y is equal to, let's say here, 2 plus 4 over 13 times x minus 10. Do you guys understand what I'm doing? The point slope thing I just did? So I know there's a point, and I know that there's the slope, so I can write the formula for the line down, right? It's like point slope says that if you know the slope is m, and you know that, x1, y1 is a point on the line, then we can write the formula for the line down immediately. I'll remind you, because I suspect that there are some people that are lost as to what I'm doing. So m is slope, the point x1, y1, then y equals to y1 plus m times x minus x1 is the equation of that line. So I'm using this result. I'm using this point slope formula. Like I found the slope here. This is 3/2, right? So I use that here, and I'm using this as my point. That's why I put x minus 1 here, and that's why I put a 4 here. For the next one, my slope was 4/13, and then I'm using 10(2) as my point. So I did x minus 10, and I had the plus 2 in the front. So I'm using this point slope. And then you guys want me to clean it up. I think, so this is what y equals 4/13 x. Now you guys got to tell me, what is 2 minus 40/13 is what? What is 2 minus 40/13? What's 26/13 minus 40/13? I think it's minus 14 over 13. Of course, you can use a calculator, right? Hey, now I have everything I need to finish case 1, right? So it's minus 3 less than x less than or equal to 1. And what can I say about y? Y is between line 3, so I've got 4/13 x minus 14 over 13 less than or equal to y less than or equal to, what's the upper bound? Line 1, right? Which is 3/2 x plus 5/2. Now, you might think this problem is annoying, but this is actually a kind of thing that comes up in calculus, because oftentimes we want to like find the area of a shape, and we're forced to like break it into pieces like this so we can integrate the separate pieces separately. So it's not just me being mean to you guys, although there's also that. But it's just a class example. I didn't put on a test yet, did I? So, by the way, the test. Something I have noticed other instructors telling their classes is that they will have a sheet of notes on the test, and the other instructors provide the sheet of notes, and then they let them write extra things on them. I don't believe in that, in the sense of I don't believe I should write the sheet of notes for you, but I am perfectly content to let you you can bring one piece of paper to the test, and you can just collect all of your ideas from the class up to that point. If that would be helpful to you, I can definitely do that front and back. Ordinary size sheet of paper. You cannot write in between the front and the back sheets. Oh yeah, I've had it. I've had people do it. Like I got a 3x5 card, and they wrote on the plies. They like took the 3x5 card apart and like ripped it like that, and then they found a way to write on the inside of the 3x5. What's that? I've only seen one student do it ever. They invented the rule for me. I mean, I was impressed. And I don't know, if you're like me, whenever I've had a professor offer to let me like have a sheet of notes on the test, what I invariably will do is write down everything in the kitchen sink on that page and then never look at it. So I actually think that constructing that page for yourself can actually be a very good sort of study guide. And I don't have, you can put whatever you want on the page. Like I don't have, there's no holds barred. I mean, you can, if you want to put like Elizabethan poetry on there, you can, you know, whatever, you know, Psalms, Proverbs, I mean, whatever floats your boat. Examples from the class, also fine, right? But there's only so much you can fit into one page. Yep.
So is everything that we've covered so far?
Yes. Yeah, so like mission 1 and mission 2, as I call them, those two homeworks, like that collects together. That's the material that's on the test. That's it for test 1, yeah. Yeah. When's the test? That's a good question. Is it next class? Next Thursday, they have next class. Oh, next Thursday, next week. Isn't English useless? Let's see here. I mean, the perennial confusion of next, you know? No, it's like next week. To be more specific, so I make a course planner in part so all of these exciting questions are answered for you on this the course planner. So in course content, right? I have like an Excel. I think I have a PDF of this in there, and if you look day by day, it shows you what we should be doing, and you can find out how far I am behind. Like today is September 1st, right? So I'm supposed to be solving equations and inequalities graphically. That's what we're currently messing with. And I had also modeling variation. But remember, what have I done? I've said no word problems, right? So I got rid of your sections 1.7 and 1.12. Excuse me. I am sure that the difficulty of this section is similar to the difficulty of the other sections because I'm sure I've added something that's not in their section. So it all works out in the end. Let's see here. So today I'm supposed to finish solving equations and inequalities graphically. And I'm going to try to come back to the mission 2 problems here if I can shut up about this stuff here pretty soon. Then Thursday we have additional examples. Next Tuesday we have quiz 1 followed by review 1, right? And so my intention would be that next Tuesday I will return your homework graded to you, all right? Solutions to the homework should be posted before then. Like I should have solutions posted to missions 1 and 2 before this week is done, all right? So you'll be able to look at how the problem should have been solved, how this should have worked out, you know? And then, I mean, I'll get the homework back to you and, you know, try to give you some assessment there. Quiz 1, of course, I will not have graded before your test because you're going to take it Tuesday. But right after we're done taking quiz 1, I will probably discuss the solution with you, right? So quiz 1 is essentially like a pretest that we're going to take together.
Can we use notes on that too?
No, it's better if you don't use notes on the quiz 1. It's really important that you don't use notes. You can, however, bring your page of notes to it. If that's what you meant, that's fine. I don't want you to have like the book or all of your notes or like your phone. It should be similar to a test environment for best results. But yeah, the test is next Thursday, which is what is that? What's today's date? The 1st, so the 8th, right? The 8th of September should be your test one. Does that make sense? Now, if you,
Next Thursday is 10.
it's the 10th? Oh, Thursday, right? We're not Thursday yet. What's Thursday? It's the 3rd, so 3 plus 7 is 10. Thank you. The 10th. Yes, you don't want the test to be next Tuesday, do you? So, great. So I hope that makes sense. I will more than likely send an announcement out just saying what I said again, because I do like to put these things in writing so that you know, in case somebody wasn't here or had to get CPR training or whatever. Yep.
When the solutions come out, like for our nations, does the workout come in? Or just the
Oh, I always post I always post solutions. So that means that I'll show you how to work it. I show you how I would work it. Now, my solution it might not have as many steps as yours might, but it should have some steps.
Because I did not figure out, even watching videos, I couldn't figure out how to do those two.
Well, we can talk about that right quick. Let me finish this problem, then we'll do that. Let's see here. So if we take these two inequalities, well, really 3, right? It's this one, maybe 4. This, and this. There's actually 4 inequalities. I suppose they would. Well, it depends on how you want to look at it. I mean, you could say, okay, to be fussy, I could just have x less than or equal to 1. If I say x is less than or equal to 1, and I also say that you're above this line and below that line, that fixes the left half of the triangle. Like the x greater than -3 is superfluous. It's extra, technically, because you already pinned this down if you're below the first top line and above the bottom line. So, I mean, but anyway, this is a good answer to describe region 1. To describe region 2, we already know line 3, right, which is what? 4/13 x minus 14/13 less than or equal to y less than or equal to. Can somebody tell me what the equation of line 2 is? I haven't done that one yet. Maybe you worked it out by yourself while you're tired of me talking? No? So line 2, the slope of line 2 is going to be, let's say, 4 minus 2 over 1 minus 10, which is 2 over minus 9, minus 2/9. That makes sense. Line 2 it's got a negative slope, right? See that? Makes sense. We found a negative slope. And so y equals to whatever, 4 minus 2/9 x minus 1 will do. So in other words, I can put minus 2x over 9, and then I need to add 4. Since you guys want me to clean it up, don't you? What's 4 plus 2/9? What's 36/9 plus 2/9? It's 38/9, right? So there you go. This set of inequalities describes that part. This set of inequalities describes case 2. And so that would be my answer. I mean, I'll just be honest with you guys. Like, I wouldn't put this on a test. I don't want to grade this. This would be a nightmare to grade. If I was going to put something on a test, I would make it much simpler. Probably something more like this, right? You know, describe this set with appropriate inequalities where I had this, like, you know, x equals to 3, y equals to 2, and then there's the line. So then you could do something like, x greater than or equal to 3, y greater than or equal to 2, and you just have to figure out what the equation of the line was. If I gave it to you, then you could just give it, suppose that this line was like minus x plus 10 or something, I don't know. That may or may not make sense because I just made it up, but so the answer to this other problem I made up, which would be simpler example, you could figure it out faster, like x beyond, the x to the right of x, the right of 3, above 2, and below that line, if I gave you the line. The thing that made my initial example more complicated is we had to stop and figure out the equations of the lines, right? And that takes time. But that is something you should be able to do, right? If I give you 2 points, and you have a couple minutes, you ought to be able to find the equation between those, equation of the line which connects those 2 points, right? That's something that you're supposed to know. You may or may not know it, but it's something you should learn if you don't, okay? And you certainly could put the formulas down that you need to do it on that sheet I was talking about, right? So I would urge you, as you're working on mission 2, which is due when? Thursday. I'm sorry about that. That's not ideal. And I will grade your homework more generously because I put a time crunch on you. Like your homework is going to be graded in a less picky way than the other section because of this. It's just it's an unfortunate consequence of me being hired mid-July and starting to teach like less than a month later, and so forth. So I'm sorry about that, but. So one of you had a question, let's go back to that. And so rest of the time today, I'm going to answer your questions about mission 1 if you have them, and I'm going to try to give you some examples that will help you with mission 2. I think that would be the best. Okay, in the number 2 on mission 1? Is that right? Okay, so let me remind myself what that is. Oh, this one. So which one? Part A, Part B, Part C? Well, just pick. Let's pick one though. Problem 2. All right. So we're supposed to figure out what A and B are, given that x to the A, y to the B, is equal to the square root of x times the square root of y, divided by x to the minus 2, y cubed. Okay. So the way to attack such a problem is to keep in mind the tools that we have at our disposal, right? And the main tool we have at our disposal is this, like x to the s, good grief, x to the t power raised to the s power is x to the ts is one thing. And we also know that if we have x to the y raised to the s power, it's x to the s, y to the s. Another thing we use a lot is if we have a negative exponent, it moves it into the denominator. And if we have a negative exponent in the denominator, we can move it into the numerator. What's the other tool of the trade here? How do we get rid of square roots? Yeah, exactly. Square root of x is x to the 1/2. More generally, the nth root of x is x to the 1 over n. So we can always get rid of radicals and work with exponent notation instead, because usually exponent notation is going to be easier to think through. All right? Me personally, I think in exponent notation. I try to get away from the radical notation as fast as possible. Mm-hmm. Okay, so that said, let's get rid of the radical notation. Yeah, everything to the 1/2 power, that outside root. X, we've got y to the 1/2 power inside. X to the minus 2, y to the 3rd, like that. And then what I would do is I would simplify the inside first. I work inside out. How can I simplify the fraction inside? Yeah, x to the 1 plus 2, right? And how about y? Oh, y to the bottom? Okay, sure, we could do that. Yeah, that's not wrong. What's 3 minus a half? Well, I'll write it down. 3 minus a half, right? Show my work here. That's 6 halves minus 1 half, which is 5 halves, right? So we've got x cubed over y to the 5 halves to the 1 half. And then we can write that as x to the 3 to the 1 half over y to the 5 halves raised to the 1 half. So maybe that's another one I should add to the list. If we have a fraction raised to a power, it's the fraction of the powers. Maybe that'd be another good one to have on our list of things we should know. So I just used that for that fraction. Yeah, so that's what? That's x to the 3 halves divided by y to the what? 5 halves times 1 half is 5 fourths, right? Yeah, we gotta bring the y back upstairs because that was the format we're looking for. So then it's just pattern matching, right? We just have to compare this against that, and you can see A is 3 halves, and B is minus 5 fourths. Yeah.
Why don't we put A equals, or B equals, right, 1 second off that?
You're saying you just wrote it, you boxed in x to the 3 halves, y to the minus 5 fourths is your answer?
Or, yeah, I just left it.
Yeah, I probably won't take points off, but I do actually want you to write A equals blah and B equals blah when it depends on the wording of the problem, generically speaking. But if you got that far, that shows that you that's the spirit of the problem. So I'd probably, if I took anything off, it would be like minuscule. Probably not. Probably I wouldn't take off. I have enough points. I don't want any more. I try to let you guys keep them. You know? My rental house in Tuscaloosa doesn't have a lot of space, so I gotta try to not keep things, you know, even hypothetical points. Other questions? So I will post a solution to the other two pieces in the when I post a solution for this. But let's look at an inequality which is kind of like one of the ones in mission 2. And I know you guys probably haven't tried yet because, well, you had mission 1 to do, right? And if you look at the video from yesterday in the other section, I solved one that is similar to the one I'm about to do, but different. So if you want to see me do yet another one of these that's kind of sort of the same but different, you can look at yesterday's video from the other section. If you're like, I need to see more Cook solving math problems. My day is more complete the more I see, me work out problems. There's like a whole other section with videos posted, and I don't just repeat what I do in here and there, because they ask different questions, which makes me say different things. But so hopefully I'll come up with something good here. If we had 4 over x plus 1 minus, let's say, 3 over x greater than or equal to, 2, we could try to solve this inequality. This would be very much similar to problem, I'm basing this on problem 12, part F, okay? So once we're done with this, I'll try to go back and do some easier problems that are of the same nature, all right? But we'll start with this one. So what makes this problem annoying is that it's not starting out in like the easy way. So what do I mean easy way? Like if I had something like, x squared times x minus 1 times x minus 3 less than 0, it might be good for me to work this. Let me actually flip the script here and work that one first and come back to this one. This one's a pain. Let's do the easy one first. The reason this one's easy is it's already factored. And so when I have these expressions less than 0, what I can do is I draw the number line and I can just straight solve it. So the algebraic critical numbers here and tell you what, I'll make it even more interesting. Let's divide by a factor of your choosing. How about x plus 4 quantity cubed there? You're like, that doesn't look easy. No, seriously, this is easy compared to that one. And the reason I say it's easy is once we have it in the factored form, all we have to do is like look and see which one of the which values here are not defined when we plug them in, or they either not defined or give us 0. So I call those numbers algebraic critical numbers. How about 0 makes that 0, 1 makes that 1, right? 0 that makes this 0. If I plug in 3 to that, I get 0, right? And how about the denominator? What are we going to get into trouble with here? No, easier than that. It's already x plus 4 cubed, so when can that be 0? Negative 4, right. So those are the interesting numbers. Those are the numbers where the sign of this expression can change from positive to negative. So I just draw a number line. I put those in order. Minus 4 comes first, right? And then I've got 0. I've got 1. I've got 3, right? And then I just have to plug in some test points to find out where it's positive and where it's negative. After I do that, I can solve the inequality. So let's start out. Let's start out over here, like number 4. What happens if you plug in 4? This is positive. X minus 1 is positive. X minus 3 is positive. 4 plus 4 is 8. That's positive. So this entire expression is positive if we plug in 4. So I can put some pluses over here to indicate that the expression is positive to the right of that. And then what would be between 1 and 3? What could we try to plug in there? 2? Okay, I like that. What happens when we plug 2 into here? Positive, positive. Uh-oh, 2 minus 3? Negative. This is still positive, right? So if you think through that, the only thing that changed signs was this factor right here. Right. Yeah, negative because we got minus, plus, plus, plus. The net number of minuses is odd, you know. Now when we get here, how about 0.5? Yeah, a half, right? There, positive. 0.5 minus 1 is negative. 0.5 minus 3 is negative. So yeah, we get plus, minus, minus,